So we're going to start out by looking at section 1.5. And 1.5 is on transformations, specifically of quadratics. The transformations we're going to learn in this section apply to quadratics, but they also apply to any function. So once you know how it works for one type of function, you really know how it works for all of them. All right, so first is, what does a quadratic equation look like? That's the general format of what it looks like. The key is that you have a formula where the highest exponent is 2. Now, the A, the B, and the C in an actual problem, those would be numbers. So here's an example. F of x equals 3x squared minus 8x plus 4. That's a quadratic type problem. The only thing that A can't be is 0. Because what would happen if you filled in a 0 for A? Want to have a guess what would happen? Yeah, Dom?
It would just be 0 on that.
What would turn into 0?
Just ax squared.
The ax squared, right. If you filled in a 0 for A, you would basically wipe that whole term out, and you'd be left with bx plus c. And that's basically the equation of a what? A what?
Linear.
Yeah, that's linear. That's a line. That's not a quadratic. That's like y equals mx plus b. It's just different letters. All right, so A, B, and C can be any letter you want, or number, positives, negatives, decimals, but A can't be 0. All right, so let's graph y equals x squared. So on the calculator, there's probably something else already typed in, so you can just go to the y equals screen. And clear. And clear. So if there's anything in there, just clear it out. Just type in x squared. So x, you have to go over one row and down one. It's the button right below mode. That's how you always do x. And squared, it's this 2, 3, 4, 5th button down on the left. X squared. Okay, before we hit graph, you always want to go to your window or go to your Zoom and just reset it in case somebody who used it changed it to something kind of weird. So let's go Zoom. And the one we always do is 6. Zoom 6 gives you a window from -10 to 10 on the X and on the Y. All right. Did people get a picture that looked like that? Okay. So if you got that, then you did it. Does anybody remember what that shape is called? It's a quadratic equation that creates that shape, but the name of the shape is? That's a parabola. And parabolas can open up, or you can flip it, and it could open down. They can graph it different ways. That's what we're going to talk about with transformations. How can we graph it different ways? Yeah. Just sign out. Now, let's look at what happens if we substitute in for x, negative x. So I want to change, in fact, I'll leave that there. But I'm going to go down to y2. And in parentheses, I'm going to put negative x, close parenthesis, and square. So I just changed all my x's to negative x's. And I'm going to hit graph. And if you watch it as it graphs it, it looks exactly the same. It doesn't look like it's any different. It just traced a red line right over the blue one. Well, something did happen there. Does anybody have an idea what happened, but you can't tell, and it has to do because the parabola is symmetrical? I have a guess? Yeah. Yeah, it did flip it. But a parabola is not a good one to see it on because it flipped it right over that red dotted line. If you flip it, it's exactly the same. Okay? So in this case, there was no difference. But we will talk about some where the negative does make a difference. Okay? But in this case, it didn't. So negatives, when you see them, these always cause something to flip. There's a difference if you put the negative in front of the whole thing, or you just put it in front of the variable. One flips it one way, one would flip it the other way. So we'll see both. Yep.
I'm getting an error.
An error? So what did you type in for your graph? Did you put, did it work with the first one, x squared?
Yep.
Okay, and for the second one?
There's a number.
And you use the negative symbol below the 3?
No.
Okay, so yeah, if you use this one on the side, that's a subtraction sign. We want to use the one below the number 3. And if you didn't do that, that's probably what's causing the error. Did it work now?
I think so.
Okay. Any other questions on that? Okay. So in this case, the y-axis is what we call a line of symmetry. If you reflect something over a line of symmetry, you can't even tell you did. It looks exactly the same. Now, does anyone remember, it's going to be the next thing I show you on the board, what the name of this low point right there is called? If you flip it over, it could also be the high point. Does anyone remember it begins with a V? Yeah?
It's the vector.
Not vector. We are going to study those at some point, so hang on to that thought for like 7 months. We'll come back to that. Yeah? The vertex. Yes. So the vertex is the low point in a parabola, or it could also be the highest point if you flip it over. That's called a vertex. Any questions on that? So this whole section is about transformations. Basically, what can you do to the parabola? How do we take it and move it left or right? I'm going to show you that. I'm going to show you how you move it up or down. And then I'm going to show you how you can stretch it up. And flip it. I'll show you that one too. All right, so now let's look at what happens when we change the number in front. So in other words, what does A do? That's what I'm trying to figure out. So I'm going to graph x squared. This is called the parent function for a parabola because it's the simplest. It's kind of the function that everything else comes from. Right? That's the base function. These other ones are some type of transformation, okay, with a number in front. Let's see what the number does. So let's try putting in 1/3. That's how you would do it. Just like that. 1/3 x squared. And let's try 2x squared. Okay, I already set my window last time. I did Zoom 6, so I don't need to do it again. It's fine. We'll just leave it like that. Let's hit graph. So first you'll see that's the original. Now let's look at what the 1/3 does. There's the 1/3, and now you're going to see the 2x squared. Okay. So
the fraction.
The fraction, just like that.
Like on the calculator.
Yep, just like, oh, how do you do it? You push the left parenthesis button. Then that's, the left parenthesis button is above the 8. And then you hit 1 and then the divided by button and then the 3.
Oh, okay.
And then the right parenthesis. That's how you do it. So what did changing that number in front of the x squared do? Oh, tell me, what did it do?
Which me?
Yeah, you.
It shortened this narrowed in and made it higher.
Yeah, so it kind of changed like the width of it.
Yeah.
And the way we describe this is called a vertical stretch. So imagine that this point was glued at the origin. If you had something that was glued down and you pulled up on the sides of it, right? Or like somebody like stretched you out, what would happen to you? You'd get longer and thinner, right? That's the black one. It was stretched vertically, so it got thinner. Imagine like you had silly putty, right? If you squish it down, what's going to happen to it? It's going to spread out and get wider. So that's the red one. That's a vertical shrink. It got compressed, which caused it to get wider. So depending on what kind of number you put in front will cause it to either stretch or shrink. I showed you one of each. What do you think the number has to be bigger than for it to stretch? Yeah? 1. Anything bigger than 1, like 2, will cause the graph to stretch. Anything between 0 and 1, 0.5, 1/3, 0.2, is going to cause the graph to shrink. So what's the effect of changing A? If A is greater than 1, it's going to cause your graph to stretch. And that's exactly how you would say it on a test. We would say vertical stretch by a factor of, and then you tell me the number. So this is a vertical stretch by a factor of 2. That's if A is bigger than 1. If A is less than 1, but still positive, not going below 0, then the graph shrinks. You can say it's like it shrunk down, right? Compressed it. When we describe that kind of transformation, we're still going to say it the same way we do the other one. I would still say that this one is a vertical stretch by a factor of 1/3. If you tell me that something is stretching by a fraction, then I know that really means it's compressing. The reason we say it that way is so we can say both of them the same way. Vertical stretch by a factor of, and then tell me the number. Bigger than 1 is a stretch. Between 0 and 1 is a compression. Any question on that? And the bigger you make the number, the more stretch you get. So if you change the 2 to like a 7, you're going to get even more of a stretch. If you change it to a 50, it's going to be even more stretch. So now let's take that same idea. We're going to change the number in front. But now I want to look at what happens if I put a negative in front. Not a negative, not this. We already did this before. Like 2 times negative x squared. We saw what happens when we put the negative inside. It caused a reflection over the y-axis. What do you think is going to happen when I put a negative in front of the whole thing? Yeah? That's going to flip it over the x. So instead of the parabola looking like that, it's going to look like that. Let's just try one of them and see. So I'll do x squared. And remember, when you put the negative in, you've got to use the one below the 3. Don't use the subtraction sign. You'll get an error. Let's do negative x squared. So it's not in the parentheses, it's in front of the whole thing. Get graph. Okay, there's your original. And here's your new one. This time we can tell that it's been reflected because we didn't reflect it over the y-axis. That we couldn't tell. But this one we can tell. So that negative causes the graph to flip and open downward. So when you describe it, you can say that you reflected over the x-axis. You could say you flipped over the x-axis. You say a couple of different ways. So any questions on that or how this negative is different than the first one? Yeah, if you want to see another example with numbers, that's a reflection over the y-axis because the negative is inside parentheses with the x. That's a reflection over the x-axis because the negative is in front of the whole thing. It's not with the x. That's the difference. Where you put the negative makes a big difference. And even if you just look at it, like think about PEMDAS, if you put the negative inside the parentheses, the negative and the x are getting squared. Over here, just the x is getting squared. The negative is not part of the thing that's getting squared at all. So it's totally different. All right, so what I want to do now is look at two graphs and describe what you would have to do to one of them to change it into the other. Again, this is your parent function. Consider that as like what you started. I want to know what I would have to do to y equals x squared to change it into y equals negative 5x squared. Okay, so first thing, how many transformations does this graph up here have? Have a guess? Yeah?
2.
Yes, it's 2. The negative and the 5 do two different things, even though they're right next to each other. So the first one we deal with is the 5. Can someone remind me, how do you say that when you put a number right in front of it like that? What type of transformation is it? Yep.
Stretch.
What kind of stretch?
A vertical stretch.
So vertical stretch by how much?
5.
Right, it's a vertical stretch by a factor of 5. Don't confuse the negative with that yet. The negative is step 2. So vertical stretch by a factor of 5. And then we have a negative in front. What's the negative in front going to do?
Goes left over the x-axis.
Right. That's a reflection over the x-axis. Reflect over x-axis. So if you did those two things to the graph of y equals x squared, it would turn into the graph of negative 5x. Okay, any questions on that? Now, there is an order that you have to follow. It's kind of like PEMDAS. If you have more than one transformation in a problem, you are supposed to write them in a certain order. We haven't had that many. We've only had 2, and I kind of led you through which one to do first. So I'll give you guys a list so you know which one you write first. All right, let's look at this. This time, we're not using a negative. I'm not putting a negative next to the x squared. And we're not multiplying by a number in front of the x squared. We're adding or subtracting a number at the end. Does anyone have an idea what that's going to do to it? Yeah?
It'll go left and right.
Okay, so it could shift it left or right. How else could it shift it? Yeah, Tom?
Up and down.
It could go up and down. Let's see which one it is. But I will tell you that adding or subtracting like this is always a shift, either up and down or left and right. You're about to find out which one. So let's graph x squared, and let's do x squared plus 2. Okay, so there's the original. And here is x squared plus 2. Which way did it shift? Up. And you can probably guess what the minus 3 would do. That would shift it down. So let's write that down. So how can we get y equals x squared plus 2 from y equals x squared? So to get y equals x squared plus 2, let's say take the original and shift it up 2. That's how I would say it. To get y equals x squared plus 2, take the original and shift it up 2. The next one, to get y equals x squared minus 3, take the original. Take y equals x squared and shift down 3. One thing that's important when you shift, you have to tell me two things. You have to tell me what direction and how much. Did you go up? Did you go down? Did you go left? Did you go right? And then how many units? 3, 6, 4. So vertical shifts are what we call a rigid motion transformation. They're not a stretch. A stretch takes something and it distorts it. It doesn't look like it did when you started. A shift moves it. Just puts it in a different spot. And in general, if you have y equals x squared plus k, if k is a positive number, if what I just circled is greater than 0, it will go up. If this is less than 0, it would go down. Now, I put absolute values around that because you don't want to say something like the graph shifted down -5 units. You can say you went up 5 or you went down 5. But don't say up or down by a negative amount. Down is negative. Right, so that's a vertical shift. And I told you that when you learn these transformations, they're going to apply to anything. So like if you had a square root function, and then you did this, what do you think that plus 2 would do to the square root function? Yeah, go ahead, Dominic. Yeah, it would go up 2. So this would do exactly the same thing that it does to a quadratic. It would move it up 2. But today we're focusing on quadratics. Any questions on those two rules? All right, so that's for up and down. Let's look at this. Okay, that's still adding and subtracting, but it's a little different. What's different? Yeah, right?
It's inside.
It's inside, right? This is inside parentheses. So it's going to shift, but which way, Cameron, which way do you think we're going to shift this time?
Negative.
So, what direction?
Right.
Right? Which one of these do you think is going to go right? The +2 or the -3? The +2? All right, let's try it. Let's graph. I'm going to graph y equals x squared. And then I'm going to graph x plus 2 squared. Okay, so let's see what happens when we graph. And you said which way again? To the... We need to say it before it shows up. That's okay. Yeah, but I think you had said it was going to go to the right. So this one went to the left. So +2 made it go to the left. So -3, which way do you think that would go? Yeah, that's going to go to the right. So that's kind of backwards, right? It's not, to me, when I think of a number line, I think positive numbers go to the right, negative numbers go to the left. It's backwards. So let's just write one of these down. So say to get y equals x minus 3 squared, take the original, and you would shift right 3. That's what the -3 will do. It's going to go right 3. So this is another example of a shift. Okay? It doesn't stretch the graph at all. So this is a horizontal shift. So I'm going to try to explain it so we can remember which way it goes for negative and which way it goes for positive. If you think you have a better way to remember, let me know. But just try to explain it the best I can. So I'm just going to reword this a little bit. Okay, so if what comes after the x is a negative, okay, like x minus 3, x minus 2, okay, something like that. If what comes after x is a negative, if what is after x is a negative, you're going to shift right. If what is after x is a positive, shift left. Or I could have said if number after x is a negative. That probably would have made more sense even. So if number after x is positive, shift left. And I like wording it that way better. Someone remind me again, what did we call that point that's at the bottom of the parabola, or it could be the top if you flip it? Yeah, go ahead, Ron.
Vertex.
That's the vertex. So when you put a number here, you're shifting the whole parabola left and right, including the vertex. When you put a number here, you're shifting the entire parabola, including the vertex, up or down. So if I ask you something like this, and say, where would the vertex be for that parabola? The only thing you have to look at is the h and the k value. We have to look at those two numbers, and that'll tell you. So this one has been shifted right 2, up 3. So this would have a vertex at 2, 3. So let me show you looking at it this way. The A does not affect where the vertex would go. All we have to do is focus on the H and the K. That's it. So when I say the new vertex after you shift it is H, K, I mean this. This, and I'm being very careful here, is the H. This is the K. Notice when I circled the H, I did not circle the minus with it. The H value is the number that comes after the minus. You have to be a little bit careful with that. H is the number after the minus. And the K, you can circle the whole thing. That one's a little different. Now, parabolas have a line of symmetry. Does the line of symmetry for a parabola go up and down or left and right? Which way does that go? Think about if you're going to draw a line on the parabola and fold it on that line. What way would your line have to go? So if you fold it, it lands right on top of itself. Yeah, go ahead, Tyler. Yes, the line of symmetry goes up and down. So when we talk about shifting left and right and up and down, only one of those changes the line of symmetry. What type of transformation would affect the line of symmetry? Moving left and right or up and down?
Left and right.
Only left and right, exactly. Because the line of symmetry is a line that goes up and down forever. If you take a line that goes up and down forever and shift it up 1, it still goes up and down forever. You haven't really changed anything. So the only value that's important when you want to find the line of symmetry is the H value. And the reason we write x equals, because in algebra, that's how you write the equation of a line that goes up and down. It starts out with the letter x equals, and then you put a number. And the number we put is the one that comes after the minus. All right, so we'll try an example of that. Okay, so here's an equation, and I want to know two things: the vertex and the line of symmetry. Let's start with the vertex, but just think in your head, okay, +2 is going to move it which way, and then -3 moves it which way. Let's start with the +2. Which way does +2 move the parabola? Lucas?
To the left.
Yes. So we're going to go left 2. So if you were at the origin, what would be the x value if you went left 2? So pretend like here's your parabola, right? You're going to shift it left 2. So where is this coordinate, where is this point going to end up?
Oh, on -2.
So -2. And then, that's not all we're doing. We're also doing the -3. So Jackson, what's that minus 3 going to do?
Can you set up what it's on?
What's the minus 3 going to do?
It's going to be the y vertex.
Yeah, that's going to shift it down 3. So this brings it left 2 and down 3. So imagine moving this point left 2 and then down 3. The coordinate would be negative 2, negative 3. There's our vertex. Okay, line of symmetry. We said it's vertical. When we write the equation of a vertical line, Austin, what letter does the equation always start with? Y equals would be for a horizontal line. X. So it's x equals. And Curtis, what letter are we supposed to use here for the line of symmetry? Yeah, we're supposed to use H. H is the number that comes after the minus sign in parentheses. So look at our problem. We don't have a minus in the parentheses. We have a plus. How could we think of it as a minus inside the parentheses? You want to think about the number after the minus sign. How could you rewrite x plus 2 so it's x minus something? Yep.
X minus negative 2.
Yes, that's how I think of it. Usually I just do that in my head. But if you ask me what's the number after the minus sign, and you give me a problem like that, in my head I'm thinking negative 2. That's the number that would be after the minus sign if you wrote it that way. And that is my H value. It should be the exact same number that you had right there. If it's not, then you didn't do it right. Okay, any question on that? So I told you that there's a certain order that we want to make sure we follow whenever we do a transformations. It's kind of like PEMDAS, but it's for transformations. Okay, a little different. The first transformation you always write down, if you have a lot of them to pick from, is the horizontal shift. The second one we write down is any vertical stretches or shrinks. And technically, these are all if necessary. You may not have certain transformations in every problem. So I'm not going to write if necessary after all. After your vertical stretching and shrinking, you deal with any reflections. That would be represented by a negative in front of the number. And the last thing is any shifting up or down. Shifting up and down is the very last thing you would write down. And if you're thinking, well, why does the order matter? You can't just write them down in any order. No. If you write them down in the wrong order, it won't work. It's like PEMDAS. If you don't follow that order, you'll get a different answer. So I'm going to put up a problem that's going to have multiple transformations. And first we'll identify how many it has, and then we'll see if we can write them in the correct order. All right. So it says, how can 5x squared plus 4 be obtained from y equals x squared? All right. So Jenna, first of all, how many transformations are we doing to turn x squared into 5x squared plus 4? Not sure. Anyone help out? Yeah.
2.
2. Can you tell me what told you it was 2?
The 5 and the 4.
The 5 and the 4. The 5 is going to do something, and then the plus 4 is going to do something else. Does anybody know which number we're going to focus on first? You don't have to tell me what it does. I just want to know. Do I look at the 5 first, or do I deal with the plus 4? Yep.
Plus 4.
So what's the plus 4 going to do? What is it?
Horizontal shift.
Let's go back and look at this. So when I had a number added on the end, which is like this one, that caused a vertical shift. And vertical shift is the last. So we are going to deal with the plus 4, but that's going to be at the end. So we're going to start with the 5. How about Curtis? What's the 5 going to do here?
Vertical stretch.
Yep. Tell me a little more.
5 factors.
Exactly. So he told me what it was and how much it was. Vertical stretch by a factor of 5. All right, so we dealt with that. Now we've got the plus 4. How about Dustin? What's the plus 4 going to do? Keep in mind, this is at the end of the plus 4. It's not in parentheses. It's going to shift it up 4 because it's not in the parentheses with the x. So then shift up 4. Those are the 2 transformations and the order that you need to write. Any question on that? And if you're wondering, what's the difference? Again, take a number in your head, add 5 to it, and then times it by 4. Now switch it. Add 4 and then times it by 5. You won't get the same answer for every single possible number you could think of. It won't work. Let's look at this one. All right, so we already did the vertex and the line of symmetry on the other problem. I just want to look at the transformations. So take a second to look at it carefully and see if you can identify how many transformations there are. Tony?
4.
Yep, there are 4 transformations. So this time we have every one of them in the same problem. Now, we don't have to draw it. That'd be a little complicated to draw. We're just going to list what the transformations are. Tony, can you tell me what's the first thing that you focus on here to get transformation number 1?
-1.
Exactly. You're going to focus on this -1. And what's that -1 going to do?
Shift it up, down. It would be a horizontal shift.
Well, if it was going to shift it up or down, that would be the last thing we would deal with. So what's the first thing we deal with?
Horizontal shift.
Yep, horizontal shift. So that -1 is going to be a horizontal shift, but which way?
Right.
To the right, yes. -1 will shift it right 1. So all you have to do is say shift right 1. All right. How about Tyler? What's the next thing I would look at?
the -3.
Yep.
Is
It would
is
be-
the vertical stretch method?
Yep, the 3 is a vertical stretch. So vertical stretch by factor of 3. Okay, so we dealt with the -1, we dealt with the 3. What about the negative in front of the 3? What's that going to do? Yeah. Flip it over which axis? Yes, a negative in front like that reflects it over the x-axis. You can think of it like this, I guess. This number is with the vertical stretch. Think of it as a vertical flip. If you flip something vertically, it would do something like this. That's a vertical flip. So it's over the x-axis. Okay, so write that. Reflect over x-axis. And now we can deal with the +4, which is a shift up 4. So as far as transformations, that's about as complicated as it can get. It had everything. Can't really get any more complicated than that. Any questions on that order or how we figured out what any of the numbers did? Okay. All right. Let's skip that. So let's look at this. So the last thing is called zeros of a function. Let me give you an example of a zero. The zero in that function that I just wrote down is 2. It's a number that I can plug in for x, and I get 0 for y. That's called a 0. So on that one, it's 2. Is there any other number you could fill in for x besides 2 and get an answer of 0? What do you think, Jen? No. Some you can. That one you can't. There is only one number you can fill in and get 0. That's the number 2. So it's a value that you fill in for x, and when you do it, the y value, f of x, same thing, the y value comes out to 0. So think about this for a second. The y value comes out to 0. Can somebody give me a coordinate that has a y value of 0? Any coordinate you want. 4, 0. Right there. What's another coordinate that has a y value of 0? 3, 0. Any point that you give me is going to be somewhere along that x-axis. What do we call a point that's on an axis? There's a name for it. Like if I were to draw a picture, like a parabola, and my parabola went right through those points. Where a graph crosses an axis has a name. Does anyone remember what that is? Yeah?
It's a point of intersection.
Yeah, it's a point of intersection. It's the intercept. So when I ask you to find a value that you could plug in for x and get 0 for y, What I'm really asking you to do, if you think of it as a picture, is find where the graph crosses the x-axis. That's what I want to know. So if you think about a quadratic, it's a parabola. There's different cases you can have. Yeah. So quadratics, or parabolas, can cross the x-axis 0, 1, or 2 times. Here's an example of a quadratic that crosses twice. Here's an example that crosses once. And when we say crosses, it's more like it touches once. How could it cross 0? What would have to happen for that? Yeah.
It would just have to be on the origin.
If it was on the origin, then that would count as crossing once. It would be the same case as that one. It would come down, touch the axis, and then go away. Yeah.
You would have to just be in one of the quadrants without touching an axis.
Yeah, it could be in one of the quadrants. Like, that's fine. It can touch the y-axis when I'm interested in the y-intercept. I'm interested in the x-intercept. So it could look like that, or it could be up here like that. The point is it's been shifted up or down. So that's how you can get 0, 1, or 2 solutions. Now, if you have an equation, there's a very quick way to tell how many times it crosses the x-axis. Let's look at this. I can tell that's going to cross the x-axis twice. Let's draw it and see. Let me make sure that I did that right. Yeah, it's going to cross twice. I can't tell you exactly where it's going to cross. That's a little bit more complicated. But right now, I'm just interested in, is there a way to quickly look at that and figure out how many numbers you could plug in for x that give you 0 for y? Not what the numbers are, but how many there are. X squared plus 4x minus 3. And I told you it would cross twice. And it does. It crosses twice. Now, everyone see that first? It crosses twice. Okay. Let's change this 4 to 2. Now, I don't think it's going to cross at all. Let's see. No, it still crossed twice. What happened? Oh, I know what happened. I would have to make this a plus. Let's try that. Now I don't think it'll cross at all. Yeah. So there's a way I'm doing this in my head. It's not super hard to figure out if it's going to cross or not cross. And what it depends on is quickly figuring out what this comes out to. Now this A, B, and C, if you remember, where do those come from? Those are coming from the very first thing I gave you. A, B, C. So A is the number in front of x squared, B is in front of x, and C is the constant. So there's 3 cases. It can cross 0 times, 1 time, or 2 times. If you figure out what b squared minus 4ac is, and it comes out negative, okay? If this comes out less than 0, then that means your graph will never cross the x-axis, which means there is no number you could plug in for x to get 0 for y. At least no real number. But for now, that's all we're interested in, real answers. If you figure out b squared minus 4ac and it comes out to exactly 0, then that means your graph will just touch the x-axis 1 time. In the last case, b squared minus 4ac, if it comes out greater than 0, then that means your graph will cross the x-axis twice. There are 2 numbers you could fill in and get 0 as the answer for y. Now, if you actually wanted to know what the zeros were, not just how many, this is only part of the formula you use. There's more to that. But does anybody recognize what b squared minus 4ac is from? The what? Yeah, that's the quadratic equation. So this is part of the quadratic formula. But it's the only part we need to answer this particular question. So let's try an example of that. Just make one up. 3x squared minus 5x minus 2. I just want to know how many zeros this graph has. And there's lots of ways I could ask that. How many zeros? They're also called roots. How many roots does this equation have? I could also say how many times does it cross the x-axis. Bless you. Right. Let's just start by identifying the A, B, and the C. Cameron, what's A in this case? 3. Okay. 1. What's B?
B is 5. Negative 5.
Oh, sorry. You go by Tony, right?
Yes.
Okay. So I'll go with you though, Tony, for that one. What did you say B was?
5.
Yep.
Negative 5.
Negative 5. And 1. What's C?
2.
Careful. Negative 2. Yeah. All right. Let's figure out how many times it crosses. Hey, Ryan, what's the formula that I need to use?
B squared minus 4ac.
B squared minus 4ac. So negative 5 squared minus 4 times A times C. Jenna, what's negative 5 squared? 25. Good. Minus. Tyler, what's 4 times 3? 12. And what's 12 times negative 2? So I have 25 minus, and when you do all this out, you get negative 24. So, Naisha, what's going to happen with 25 minus 24?
It's gonna be 25 plus 24.
Right, that's just going to become a plus. And 25 plus 24, that gives me how much? Yeah. 49. Doesn't really matter exactly what it comes out to. What matters is it came out to a positive result. So what does that mean? How many zeros does this graph have? 2. Yep. This graph will cross the x-axis twice. Where does it cross? Well, we could go through and do the whole quadratic formula to figure that out. That's all I wanted to know. Any questions on that? Okay, so that was section 1.5. Okay, so first section for this week. So homework for 1.5. I'm just double checking 18. I'm going to change one. Let's do. Let's do 19 instead of 40. And that's good. Okay, so that's the homework. So 1, 7, 10, 18, 19, and 22, 28, 33, and 44. So nine questions. Okay, we'll take a look at that first thing tomorrow, and then we will start chapter 2.